I have two very people. They've written a great book called Super Genes, Dr. Deepak Chopra and Dr. Rudolph Tanzi. Dr. Chopra needs no introductions. He's written more books, been on more television, done more things about healthy living, with more interesting, unique, and occasionally even controversial theories. Dr. Tanzi comes from the Harvard. Need I say more? You know, it's and together you've written a book. Is this your first book you've written together?
This is our second book.
Second, okay. Book, yeah. I've done my homework, obviously. But actually, I have read the book. I was fascinated by it. My wife, who's a retina surgeon, is already tired of hearing from me about it. And I want to talk to you about it. And the first is, it's called Super Genes, but actually you talk about epigenetics. Could you explain, first of all, what epigenetics is?
Do you want to go first?
Epigenetics, epi means onto, and the idea is that when you engage in certain lifestyle activities with a frequency that becomes a habit or a routine, that gene activity actually gets programmed semi-permanently because chemicals actually modify the genes and keep them firing, keep them active in a certain way. So it says that your lifestyle directly programs your genes. That can be good habits, good gene programs, bad habits, bad gene programs. This is relatively new information that you can actually wire your genes based on your lifestyle in a semi-permanent fashion.
And the way you change the expression of your genes can be transferred to the next generation, at least in animal models. But we believe that that's also true for all mammals because we have similar genes, you know, so since 80% of your genes are the same as a mouse and 65%, what applies to other species applies to us. But it is not only about epigenetics, it's also about the interaction between your genes, epigenetic programs, and the microbiome.
I want to get to that.
Okay.
I want to stick on epigenetics 1 second. Okay. This is fundamental. Because all of us here were raised with the concept that the genes we're born with are the genes we die with. And you're saying that's not true.
Well, they're the same genes, and unless you do CRISPR-Cas editing, you're not going to change the gene sequence itself. You're going to keep the same genes. But what matters most for health is the activity or the expression of those genes. And your lifestyle directly is regulating their expression. And whatever you do most frequently, where there's a habit or a routine or something that has a very high intensity, like a traumatic event, can cause chemical modifications to keep genes active in a certain way, whole programs of hundreds or thousands of genes at once. So now there are pharmaceutical companies. Biogen just bought a biotech company for $500 million yesterday that's making drugs that reprogram genes epigenetically. So this is here to stay. It's going to be the next big generation of drugs coming out for disease.
Could you give an example of the proof of epigenetics?
Our own study.
Well, yeah.
How about the goat?
Huh?
The goat.
The goat.
Two-legged goat.
Yeah, well, the two-legged goat is an example of a goat that was born with defective forelimbs, and she then learned how to be like a human, to walk with two legs. That's an animal example. But, on an everyday basis, when we say turning the genes on or off, it's like a light switch. You can turn a light switch on and off. But it's also like a thermostat where you can increase the volume or decrease the volume. Yeah. We have just finished a meditation study.
You keep trying to go ahead of me, Doctor.
Okay, sorry.
So what happened to the goat's offspring?
The goat's offspring. You want to share that?
You can predict that they would inherit the same epigenetic modifications that allowed that goat to adapt, but it wasn't looked at. But there was a study in mice that was fascinating where mice were trained to be afraid of the smell of cherry. So every time the mouse would smell cherry, these were male mice, they would give it a little shock to the foot of the mouse. I don't do these experiments, but I like mice. But basically, a little shock to the foot. So now, whenever the mouse smells cherry, it's trained to start quivering in the corner of the cage. Then they look at the baby mice born from that male, and these are mice just born, and they expose them to the cherry smell, and they quiver in the corner. They were never trained to be afraid of it. They look in the DNA. They seem the same epigenetic modifications in the father were in the baby mice, meaning that they inherited a new trait that the father basically was conditioned for as an adult.
I wanted to get this out there because so this is now accepted science. Epigenetics is real.
Yeah.
You guys didn't discover and invent it. That's not really even the main point of your book. But the point in part is that there are genes, and they're important, and we spend a lot of time studying them, but we've learned a lot, and the science is changing. But there's also, you spend a lot of time talking about what's in your gut. Tell us about that and why it's important.
So in your gut is what is called the microbiome, but it's also in your skin. It's also in all the orifices of your body, and there are 10 times more microbial cells in your body than there are human cells. So technically speaking, you're all a few human cells hanging on to a bacterial colony. When you count the genes of these bacteria, it's 150 times more genes that are of microbial origin than of human origin. So, and we acquire these when we are born, as we come out of the birth canal and through the bonding with the family, etc. So there's a horizontal transmission and a vertical transmission. The microbiome is your second genome. It's actually probably more important than the genes that you acquired from your parents. And it responds to things like sleep, diet, food. So if your food is contaminated with steroids or chemicals or pesticides, probably GMO or insecticides or anything that's given to animals in production of animals like antibiotics and hormones, then the ecosystem of your microbiome, which is the first thing that comes into contact with your food, will get disrupted. And what we call supergenes is the integrated activity of the microbiome, the human genome, and epigenetics. So this is a very important area right now to look at how the microbiome influences your well-being. It's not only food, but stress, sleep, meditation, exercise, yoga, breathing techniques, emotions, all affect the microbiome.
And if I might add, the two most important things you can argue that the microbiome control are inflammation in the body, and there's also something called the gut-brain axis. So the bacteria, and whether they're healthy in your gut, directly control mood, energy level, and even inflammation in your brain, which is a major risk factor for Alzheimer's disease. So we're actually doing experiments trying to treat Alzheimer's in mice for now by managing their gut microbiome.
So when you say I have a gut feeling about such and such, you're not speaking metaphorically, you're speaking literally. In fact, you can probably trust your gut feelings a little more because they haven't yet learned how to doubt their own feelings.
So in the last 48 hours, we've seen the CEOs of IBM, Intel, and Samsung on the big keynote stage talking about devices which measure a lot of your physical attributes. There's even a partnership IBM announced with Under Armour. And so you could track yourself over time. How do those things play into what you're talking about? Yourself and tracking and getting feedback and what you eat and the calories you burn and your exercise and your sleep.
So there are a lot of devices. I'm wearing a bunch of these right now. And what you can do is you can see the correlation between stress, breathing patterns, what is called heart rate variability, and now because of the very interesting mathematical algorithms, you can see the correlations, hopefully, with things like proteins and even RNA activity and genomic activity. That hasn't been done yet, but it will be. Also, I'm here with some people from the what is called the virtual reality community. So if you put yourself in an immersive environment, that environment will actually change your total gene expression. So the future would be then to use these technologies, the integration of these technologies and immersive experiences to treat things like diabetes or heart disease. Now, Rudy is talking about the epigenetic roadmap where we can actually see through the folding and unfolding of these proteins called histones, even things like mutagenesis, right? So even mutations for cancer are affected by all these lifestyle changes, right?
Right. So, yeah.
So to talk about how we might in the future be through immersive environments, be actually reprogramming our genes.
Well, two of the biggest risk factors as we age for our brain and for our body is stress and inflammation. And stress causes inflammation. largely through the microbiome, as we're learning. So for managing stress, I would say virtual reality, using this as a tool to somehow quell agitation, treat depression. This is going to be very powerful, and we'll be able to quantify the effects by looking at epigenetics, looking at changes in the entire genome and gene activity. So this is where it's going. It's correlating remote sensing of various, blood pressure, heart rate variability, and correlating that with changes at the genetic level, and then asking, what do we need? What can we do with virtual reality to actually make ourselves healthier, managing stress, helping with sleep, even helping with diet, and other things.
So, Gary, one thing I think most people don't know is that and I didn't know this till I got to hang out with this guy, only 5% of disease-related gene mutations are fully penetrant, which means there's a 1-to-1 ratio with the mutation and the disease. 95% are influenced by other factors.
Factors being stress, diet, exercise, things like that?
Yes.
Emotional state.
State.
Sleep.
So what I hear you saying is, well, we've been talking about virtual reality in this context is for fun, for education, for business purposes. There's a new purpose you're talking about that's probably more significant, and that is virtual reality can get us healthier.
And even other types of therapies. I mean, my colleague David Ron is here. We're launching an app called Spark Memories Radio. It's for Alzheimer's patients, caregivers, so that they can program music that treats agitation and depression and also sparks new synaptic activity in Alzheimer's patients. Even something as simple as playing the right music. We're emotionally attached to the music that we like between 13 and 25. So you play that music for the patient. Now add to that VR, you can do a lot for patients.
VR. So I used to work at a VA hospital where we played music from World War II, the music that was prevalent to these veterans who had been traumatized. But when you play that music, suddenly even some of them in semi-coma or coma would start to respond. So this is, when you add virtual reality, the immersive experience
even more
to the music.
So yes, there's a great documentary, Alive Inside, about how Alzheimer's is transformed music.
You're right.
And to the point that a couple provinces and several states are paying for all their Alzheimer's patients to have iPods with the music from their youth.
We're doing it on the
sometimes discovering that's a bit of a challenge. But you're saying add virtual reality to that. Now, has that been done, or are you just talking about it?
No, we're talking about it.
So this is an opportunity, because Alzheimer's is one of the great I was talking from the stage yesterday about Alzheimer's being one of the big issues for mankind, where there are other technologies. I didn't mention this because I didn't know about it until this moment. But it's a great idea, and I applaud you for it.
But the way we're doing it is on iPhone, so you have the caregiver with the patient, and by playing the music on the iPhone, now they can have a meaningful communication and interaction because you're actually getting synapses firing in the music memory part of the brain that never gets affected in Alzheimer's, no matter how far along.
See, our emotions and our memories are linked very frequently to the music we heard. So for me, when I was in training as a resident, when we did surgery, the music I heard was the Beatles and Barbra Streisand. And as soon as you hear that music, you recall all the experiences
including
of that time.
Including your stress.
Including my stress.
Maybe so.
But what happens is, imagine producing the environment in which those memories were programmed. Because, it's not fact memories that we remember. What we remember are emotional memories. If we can re-enliven that experience, you can actually stimulate the brain to become active and bring forth those memories. In fact, the part of the brain that is response to music is not even affected in Alzheimer's, right?
It doesn't get it. The pathology works all around it, doesn't hit it. Yeah.
Well, this is a cause near and dear to me. My mother had Alzheimer's and died from it, and it was a lot of the things which could have made a difference, like facial recognition and some of the other technologies out there, are still today not available for reasons that have nothing to do with wholeness and wealth, like some people are concerned about privacy now. But with virtual reality, you're opening a whole new world there. Could you help us out? So 10 years from now, what do you expect to see in wellness and healthcare using technology that we do not have today?
Well, I think first we need the integration of all these technologies. Because when you integrate all these technologies, you realize that your mind, your brain, your body, your gene expression, epigenetics, microbiome, immune system is one system. It's not many different systems, and it's an integrated system. So in medical school, we never learned about the healing system, but that's the fundamental system to which all these systems are subservient. So what I see 10 years from now is, with the exception of those 5% of disease-related gene mutations which are fully penetrant, for which we'll need new drugs based on how to stop those expressions, 95% of chronic illness will be something that technology and bioregulation, not biofeedback, but bioregulation will help us not only prevent, and I'll go on the limb and say maybe Rudy won't go on the limb, but I'm used to doing that, that we'll be able to not only prevent these diseases, reverse them. So what we're seeing is an era of personalized medicine, which is participatory, which is preventive, which is reversible, and which is process-oriented. And it's all here in one little device.
That sounds great. You want to add anything?
I would just add that we'll be using remote sensing and what we call quantification of self as a way to also look for the warning signs, biomarkers that disease is coming long before symptoms. Before cognitive symptoms appear. So to get a better idea of whether you're on your way to disease, this will tell you whether lifestyle interventions or pharmaceuticals or even non-invasive therapies using electromagnet, so big push now on electromagnetic type therapies. So the combination of these will be used to prevent disease before it strikes, but a lot of the remote sensing will allow us, even VR, to see who's on their way to disease so we can actually empower them with a way to prevent symptoms.
We thought of the body as a physical structure, but now we can also understand it as a biofield. Biofield where everything is integrated as one holistic process. And that's a very important breakthrough in just the way we think of the body. Molecular biology took us to one level, and now we're going to go to the next level. Energy, information, and dare I say consciousness.
How about aging?
Well, we know that the biological markers of aging, like blood pressure, bone density, body temperature regulation, hormone levels, immune function, are all variable. They don't correspond to your chronological age. And we now have a study looking at telomerase, which is the enzyme that regulates the length of your genes. You want to share with Gary our findings on the telomerase and gene expression study?
Well, we're looking at the effects of meditation and quantifying the effects of meditation on gene activities, on inflammation, biomarkers for Alzheimer's, and also telomerase. And with a 1-week intervention of meditation as a clinical trial, the telomerase activity, the anti-aging enzyme, went up 40%, which was totally shocking to us. We never thought we'd get such a result. And when we looked at gene activities after a meditation trial for a week, we saw that genes involved with inflammation were quelled, genes involved with wound healing were also affected, genes for viral infections. In other words, the body was chilling out and saying, we don't need to turn on these genes that they're trying to help us. So it led to a healthier genetic state. Beyond our wildest dreams, we never thought we'd get results so strong. And that paper is now under review and should be published soon.
So wouldn't some people say when you say 95% of illness is actually controllable, is what I'm hearing you say. Aren't those people that get in cancer, Alzheimer's, heart disease, and others, you're saying, well, some people say you're saying it's your fault.
No,
we didn't have the information. We now have the information, and we didn't have the information on how to change that. But now we do. So, how can it be your fault if you don't know about it, right?
Yeah. So from this point on, it's your fault.
Yes.
As
it's your responsibility. It's not your fault, but it's your responsibility to participate in your well-being. That's why I said personalized, preventive, and process-oriented, and that's the future.
But to me, now that we know how important sleep is, I would say if you're over 50 and you're not trying to get 8 hours of sleep a night, it's almost like smoking cigarettes or sitting on the couch and eating potato chips all day. It's an obligation, not just a recommendation anymore. That's where we're going with the amount of science that's supporting these things.
Right?
Yeah.
I have a device that tells me how much sleep I get. I'm certainly not getting 8 hours, especially in Las Vegas.
Just at least try.
How many of you get 8 hours of sleep a night? Wow.
Not bad.
Wow. How many of you get less than 6 a night?
That's
Most
bad.
of you.
Yeah,
All right.
Yeah. That
So
has-
how about these people like Dr. Jim Malt, who's the chief medical officer of Qualcomm? He says he gets 3 or 4 hours a night, and that's all he needs.
Well, I spoke to him this morning, and hopefully we'll change that.
Yeah, we changed that this morning.
You talked to him?
Yes.
He's all set.
I believe that when I see it. Of course, actually, I really don't know how much sleep he gets. So you recommend in this book, you have a kind of a good, better, best approach. You have easy choices, hard choices, and experimental choices. And you talk about sleep, exercise, stress, meditation, nutrition.
Yes.
What is it you think most people, if there was one thing they could change as a result of a conversation, a 2-minute conversation with you, what would it be other than sleep?
I would go with diet.
Diet.
Yeah. You always
Spend a
read.
minute about diet.
Yeah.
Anything that's processed, manufactured, refined, GMO'd, industrially produced, comes in a can, has a label, is full of steroids, chemicals, hormones, is not good. So the farm-to-table movement is an expression of how we need to change our diet. And he's right, because no matter what else you do, you all eat, and that's the first thing that your microbiome will come into contact with, and therefore that's the easiest thing to change.
So I heard organic, I heard processed, I also heard GMO. What evidence is there that GMO...
There's no evidence right now on GMO, but since GMO changes the gene constituencies of the food that you eat, and the microbiome is an ecosystem that has evolved over literally hundreds of millions of years of time, it only makes sense that the GMO foods will disrupt this, but the science is not out there yet.
But can I ask a question about that? Because there's evidence that genes, for example, and take genes from a monkey that can see with color to a monkey that's colorblind and injecting the... So you're taking genes that are not part of someone's body, a monkey's body, and giving them some strength. So why would GMO be bad?
Well, you can cut and paste for a particular GMO in your food. I think you're disrupting the ecosystem.
Well, that's the thing is, it's GMOs are bad for the planet, for Gaia, so to speak, than they are for us, because they're offsetting the natural ecology of plants, insects, and those interactions. Eventually, that's going to backfire.
I thought that was what Mendelian genetics has been doing for the last 100 or so years, is modifying agriculture. That's GMO.
But so has the whole industrial economy creating climate change, right?
Yeah, GMO is Mendelian genetic hybrids on steroids, and it just goes too far, you could argue. Because
so we don't know. We don't have the scientific proof.
I just would rather the hungry people who are getting fed around the world because of GMOs probably would disagree with you.
It can be, no, you can argue it both ways.
You can argue it both ways.
But I understand your point. I will say that my wife and I have, if I could share, a New Year's resolution that we will cut down on processed foods. There's just about 1 minute left. Is there someone in the audience who would like to ask a question, or anyone have anything they want to ask?
To a large extent, prevention and treatment are the same. In Alzheimer's disease, we don't call it Alzheimer's until you see symptoms of dementia. But the disease began 20 years before. The pathology was already in the brain. Tumor, you say you have cancer, you don't wait for the symptoms. Well, it's the same. We don't say it for Alzheimer's because you don't want to say you have Alzheimer's disease if there's no dementia. There's a social stigma that might come with that. But the fact is, the pathology is accumulating 20 years before. That's when you start treating the disease. You could call that prevention of symptoms. But prevention of symptoms of a disease that starts 20 years before is still treatment. So it's going to become more of a word issue that a lot of diseases that are age-related begin way before symptoms, and prevention is actually just treating the disease before symptoms. That's the way we look
already
at
have
it.
evidence for the reversibility of heart disease. Coronary artery disease can be reversed, but now we're seeing evidence for other chronic illnesses like bronchial asthma, rheumatoid arthritis, anything that's connected with inflammation.
So prevention, but think of it as treatment prodromally before symptoms. That's going to be the future.
But we can do if the chicken has antibiotics, the meat has antibiotics, and we do resist every day to these antibiotics. So what we can do, all the food in general is not healthy.
That's a big problem.
True.
It's a big problem.
Well,
That's why I'm a vegetarian.
Do you have anything you wanted to say that we haven't? No. So I just want to say it's a great book. I actually really enjoyed it. I learned a lot. I will be changing my behavior as a result. I especially appreciated page 239 where you talk about a cell's wisdoms, 9 essentials. I thought it was brilliant.
Thank you.
It's pretty deep, but there's a lot of really practical advice about every aspect of your life as well as these great leading-edge theories. So I wish you luck. I think you're on it's not luck, I guess. It's hard work and a lack of stress. But you're on a great path, and I love your discussion about virtual reality. Ladies and gentlemen, thank you very much for joining us, and thanks to these great authors.
Thank you.